Okay, so in graph, there is one standard question, which is we have to check whether a graph is bipartite or not. That means it is also called as two colorable. And that is simply if you have to color the graph, will you be able to color it using just two colors such that no adjacent vertices are colored the same? For example, if you see this graph, if 5 is colored as, let's say colors are red and blue. If 5 is colored as red, then 1 should be colored as, they are together, they are joined. That means two joined nodes cannot have same color. If 5 is colored as red, 1 should be colored as, yeah, blue. So we have two colors, Srinivas, red and blue. If 5 is colored red, 1 will be colored blue. Now if 1 is colored blue, then what will 2 and 4 be colored with? If 1 is colored blue, these should be colored red. Now they both should be colored red because they are adjacent to it. There cannot be two nodes connected together having same color. If these two are red, then these two must be blue. Now see, 4 is red, 6 can be blue, 2 is red, 6 can be blue. So we use one standard DFS variation to check whether the graph is bipartite or two colorable or not. So if graph is two colorable, that simply means we can divide them into multiple groups. So this is the first check that we needed to know whether they are colorable or not, or whether they are divisible in the groups or not. So if you see the first condition that I had here is, first take the edges, convert it into graph notation. So I just have a simple function to create a graph. So if you see, all it is doing is it is just creating a vector of vector. U is connected to V and V is connected to U. So this is just to convert our edge list to adjacency list. Once we have adjacency list with us, second thing that I'm doing here is checking if the graph is bipartite or not. If graph is not bipartite, then simply there is no solution possible. So this is returning -1. And bipartite is what we were talking about. It's a standard DFS variation. So we are starting with any one node in the graph, and we are giving it some color. So I used here color 0 and 1. I'm calling this initially with color 0. Now if this is colored 0, its adjacent neighbors will be colored with 1. So I'm just doing negation of 0. So 0 gets converted to 1, 1 gets converted to 0. So it's a DFS variation. You can treat like color as a visited array, and we are going with a simple DFS here. Yeah, people who understand DFS would have this idea what this recursive code is doing. Right? Okay. Now the key idea. After bipartite check is done, it says the graph is bipartite. That means you can color it with 2. What essentially we are doing is we are routing the tree. We are routing the graph on every node as root, and we are just asking how many maximum groups are formable with I as the root. So this I will talk about with little drawings so we understand and visualize this better. So let me just go back to my screen share.